The quadrilateral ABCD is a trapezium in which AB is parallel to DC. We have the position factors of ABC. Given that DC equals 3AB, find the position factor of D. So just draw a simple diagram first. Trapezium, ABCD, DC is 3 times AB. Write down the coordinates of ABC. We are looking for the coordinates of D. So just look at the pattern. As you go from B to A, what is the process? From 1 to -1, the process must be -2. So 1 minus 2 is -1, 3 minus 1 is 2, 1 minus 2 is, 1 plus 2 is 3. So this is the process, or this is called the factor BA. Now since CD is 3 times of that, just multiply by 3, -6 minus 3 plus 6. Therefore, that's the process to go from C to D. So from C, 2 minus 6 we get -4, 2 minus 3 we get -1, -3 plus 6 we get 3. So that's how we find the coordinates of D. Or you can write it down algebraically like this. We're looking for OD. OD is OC plus CD. So when you have addition of factors, they have the same letters, they kind of like cancel out. We have only OD here. So the OC is the coordinates of C. This is the coordinates of C. And CD is 3 times BA from here. So CD is 3 times BA. So the BA is OA minus OB. So if you have coordinates of the displacement factor BA, that is the coordinates of A minus the coordinates of B. So A minus B, we have A, we have B, so just subtract, you get the factor BA, right? So we multiply by 3, so we add and we get exactly the same result. So that's the coordinates of D. Now the factor equation for the line through A and B. So line through A and B means we can use the point A or B and the direction factor AB or BA. So here we're using A and the direction AB. So this is how we write the factor equation using a parameter like lambda or mu or whatever variable. Now find the distance between the parallel sides and the area of the trapezium. So we already know the position factor of D. We can find the factor AB or BA. So actually we have already found BA and CD actually. So to find the length, we use the square root of the sum of square of each component. So this squared, this squared, this squared, add everything, take the square root, we get the magnitude or the length of the factor. Same thing with this, we can do the same thing, or just remember it is 3 times, so 3 times 3, that's 9. So we have the sum of the parallel sides. Now we need the height of the trapezium if we want to find the area. So to find the height of the trapezium, let's just find the angle theta here. So this P is the foot of the perpendicular from B to the base here. So the height of the triangle is BP. The theta here is this angle. So using the dot product formula in the MF19, CD dot CB is the magnitude of CD dot the magnitude times the magnitude of CB times cos theta. So for CD, we know that already, that is CD. And for CB, well, CB is B minus C. So 1 minus 2, we get -1. 3 minus 2, we get 1. And 1 minus -3, we get 4. That is the factor CB. So again, from the coordinates of B minus the coordinates of C. And for the magnitude of CD, we know already it is 9. The magnitudes of CB, again, we use the sum of the square of each component. So -1, 1, 4, square everything, add everything, take the square root. Okay, that's the magnitude of CB. And now to do the dot product, we multiply the corresponding components, -6 times -1, -3 times 1, 6 times 4, and add everything. So use a calculator, we get 27 here. use a calculator, we get 3 root 2, and we divide both sides by 27 root 2, we get cos theta. Okay, so we know the value of cos theta. Well, actually this is 45 degrees or pi over 4 radians. So since root 2 over 2 is cos, so cos is adjacent over hypotenuse. So if you use Pythagoras, we get root 2 also. Basically it's 45 degrees, it's isosceles right angle triangle. Okay, so if you're looking for sine theta, that's going to be opposite over hypotenuse, so it's also root 2 over 2. So from cos theta, we can find sine theta. So now that we have sine theta, we can find the height of the triangle here. So we already know that this is the length of AB, length of DC, and for the length of BC, actually it's here, length of BC or CB, same thing, it's 3 root 2. Okay, so this length is 3 root 2. And we use sine theta is opposite, which is h, divided by the hypotenuse, which is 3 root 2. So multiply both sides by 3 root 2, we get the h. So h is 3 root 2 sine theta. We already know this is sine theta, so the h is 3. We have the height of the trapezium, and the area is 1/2 times the sum of the parallel sides times height, and we get the area. Alright, I'll see you again next time.